So for topic 26, inverse functions, we're going to talk about the characteristics of the inverse functions and how to find a function's inverse. Okay. So a lot of these functions we've already been exposed to. So looking at concept 1, we're given some examples of what inverse functions look like based off of our common functions that we've already learned. So, for example, an inverse function is a function where the x and y values are swapped. Where the x and y values are swapped. That can be in many different formats. We could have a table of x and y values, and then we just swap those x and y values, and that would give us the inverse function. Some common inverse functions are from a quadratic. So if you remember, a quadratic is where f of x is equal to x squared. So any terms of x squared. The inverse of that, if you swap the x and y values, you get the square root of f of x. Remember, f of x is the same as saying y, so the square root of y. For exponential, remember that was f of x is equal x to the n power, where n is any numerical exponent. The inverse of that would be f of x to the 1 over n power. So again, f of x is y, so that would be y to the 1 over n power. Natural exponential, so that f of x is equal to e to the x. The inverse of that is natural log of f of x. And then lastly, a common example is the logarithmic function, which is f of x is equal to a to the x, and the inverse of that is log base a of f of x. Okay. Notice when we switch those x and y values, we have to get that new y value by itself. When we do that, we are taking whatever we need to do in order to cancel out the previous thing. So notice in natural exponential, we had e to the x. In order to cancel it and reverse it, we had to do the opposite, which was natural log of x. Same with that logarithmic of base a to the x. We do the opposite, and we do log base a to f of x. This will pop up on the final. Now let's look at some examples. So in these examples, it wants us to find the inverse. And then once we find the inverse, it wants us to define if the inverse is a function. How do we determine if something is a function? Do you guys remember? Especially looking at tables and points.
No repeat x's, right?
No repeat x's, yes. So x's cannot repeat. X's cannot repeat. So again, remember the inverse means we are going to swap x's and y's. And then remember, we know if something is a function if the x's don't repeat. So just looking at our function at the top, our original function, if we were to label all the x and y values, so x, y, because these are points. Looking at just the x's, do any of these x's repeat in this function? No. So that means the original function is a function. So we say f of x is a function. Okay. Now let's find the inverse. So the inverse is f inverse of x. That's how we write the inverse. And how we're going to do that is we're just going to swap these points and put the y value first. So instead of 3, 4, our first one's going to be what? 4, 3. And then instead of 1, -2, it's going to be -2, 1. We're just flipping all these points. And then instead of 5, -1, it's going to be -1, 5. And then lastly, instead of 0, 2, 2, 0, bless you. So this right here is our inverse. All we did was swap our x and y values. Okay. Now looking at our inverse, can we still say this is a function or not a function?
Yes.
Good, it is a function, because if we look at all our x values, our new x values, none of those values repeat. So that means our inverse is also a function. Okay. Okay, go ahead and do the same for number 2. So number 2, instead of listing it as points, it's listing it as a table. So I first want you to look at this function and tell me, is it a function? And then find the inverse and tell me if that inverse is a function. So you should be creating a whole new table next to it and swapping your x and y values. Those of you coming in, we're doing topic 26. Okay, about 30 more seconds to do this, and then we'll go over it. Okay, so looking at this table, is this a function or not a function? The original one is a function. Good, because none of the x values repeat. So I'm going to say f of x is a function. This is the original one. Now I'm going to redo my table, and I'm going to swap my x and y values. Okay. So now these are going to be my new x and y values, or I could just write this as y and x. So I'm switching them. Okay, but remember, these are my new x and new y. Okay, so instead of 1, 2, you should have wrote 2, 1. And then 0, -2, we're swapping each of these values. 3, -1, -1, 0, 1, 2, -2, 3, 5, 4, and then lastly 1, -3. So this y value that we swapped from the original equations is our new x's. That first column is our new x's. So now looking at our new table, our inverse, is this a function or not a function? Good, it's not a function because our new x's have 2 1s. That means we have a repeating x, so this is not a function. So we say that the inverse is not a function because of the repeating ones. Okay. So that's what it would look like if you're given points and a table. Okay. And the next examples, we're just given equations. So in this part, it's asking us to graph its function and its inverse by creating a table of values. So we're first going to create a table of values for our function, and then we're going to use the concept of swapping the x's and the y's to find our inverse table. Okay. So first we're creating a table for this function. And remember, when we're creating a table, it's best to choose some negative numbers, 0, and some positive numbers. So for this one, I'm just going to choose -5, 0, +5. And your numbers could be different. Okay, so I'm just trying to find some points here. So once I pick my points for x, I'm going to plug them back into my equation to find my y values. So for the first one, I have -1 minus 1/5 times -5. Remember, you could type this whole thing into your calculator here. Just don't forget those parentheses. And then you should have got 0. Okay. And I'm going to do the same for both 0 and 5, so you can practice plugging this into your calculator. So -1 minus 1/5 times 0 gives us -1. And -1 minus 1/5 times 5 gives us -2. So that means some points for our f of x is going to be what? What would be our first point? -5, 0. And then what? Yep, 0, -1. Remember, we're looking at the table of what we just found. And then what's the last one? 5, -2. Okay. So since we're not given the equation for the inverse, we're just going to take these points to find our inverse points. So remember, we're swapping our x and y values, so what would be our first point for our inverse?
0, -5.
0, -5. What about the next one? -1, 0. And then the last one? -2, 5. Good, we're swapping our x's and our y's. Okay? And from here, we're just going to draw a rough sketch of both so you could see both of these functions on one graph. So I'm just going to highlight these ones in different colors. And then I'm going to go ahead and plot my original function. So I'm going to plot -5, 0. And then I'm going to plot 0, -1. Remember, these are just a rough sketch. Okay? And then I'm going to plot 5, -2. Okay, so this is my first one, which was a linear equation. And then I'm going to do the same thing for my inverse points. So now I'm plotting the opposite. So now 0, -5, -1, 0, and -2, 5. So somewhere up here. Again, this is linear. I'm going to connect it like this. Okay. So this is showing you on one graph the original function and the inverse function. Okay. Remember, this was a rough sketch, so I just plotted 3 points and connected those points. Any questions on how I set up 3? Okay, go ahead and take a minute and try 4. You're going to do the same thing. Create your original table, and then flip your x and y values to find your inverse function. And remember, you can pick any points you want. So your table might look different than my table. It's also a great time to practice using your calculator, plotting these points, putting the information in the calculator and see if you get matching data. Okay, about 30 more seconds, and then we'll start going through it. If you're still working, you can continue working through the problem as I go over it. Okay, so what I'm going to start doing is setting up my table. Remember, my table can look different than yours depending on what x values you chose. I'm going to go ahead and choose the same x values I did on the last one, so -5, 0, 5. Okay. So plugging my numbers in, I have 1 over -5 minus 1. Again, plug that into your calculator. And since we're graphing, just leave it in decimal form. So for this one, I got -1.6, which is -0.167. Then plugging in 0, I have 1 over 0 minus 1, which is -1. And then for 5, 1 over 5 minus 1, which is 1/4. Same as 0.25. Okay. So if I was to write these out as points, and again, you don't have to do this step, I'm just so you have that visual for your original function. I have -5, comma, -0.167, 0, -1, and 5, 0.25. Those are my points for my original function. And then how'd you guys find the inverse points? Good, flip all those points. So instead of xy, we're putting in yx. So I'm just flipping those points. And that is going to help us plot our inverse. And I just highlighted 2 different colors so you'll be able to see the 2 different graphs. And then I'm just going to plot my points here. So my first one, I have -5, -0.167. So again, this is super rough sketch. It's going to be somewhere over here. Then I have 0, -1. let's see, right here, and then 5, 0.25, so up here. So notice, remember, looking back at our original equation, we have the x in the denominator. So is this linear? No. So notice how our graph has some curve to it. So don't just try to connect those points. We're going to have some curve to it. Okay. So that means when we do our inverse function, we'll still see that small curve. So plotting my opposite points, I have negative 0.167, negative 5, negative 1, 0, and then 0.255. So again, rough sketch, connecting for my inverse. Okay. Any questions on 4? Okay, we're going to do the same thing for 5. Notice when we graph this, is this going to be linear? Is it going to be quadratic? No. What does that 3 tell us up there? It's going to be cubic. So we're going to have a couple curves in there when we're drawing our graph. We just got to keep that in mind because we are not creating a very large table. Okay, we're doing the very minimum for points. Okay, so I'm going to go ahead and pick some points. You can do this along with me and pick any points you like. I'm going to pick negative 2, 0, 2, and then I'm going to start plugging in those numbers. Again, you could continue doing negative 5, 0, 5. It's completely up to you. This is just to form our rough sketch. So plugging in negative 2, I have negative 2 times negative 2 cubed plus 1. Again, this whole thing can be typed into your calculator. Just don't forget those parentheses. And that gives me 17. Then I'm plugging in 0. Negative 2 times 0 cubed plus 1, which gives me 1. And then lastly 2, negative 2 times 2 cubed plus 1 gave me negative 15. Okay. So from here, that just gave me points for my original function. So I have negative 2, 17, 0, 1, and 2, negative 15. And I'm going to use this information to find my inverse by doing what? Good, I'm swapping my x and y values. So then I have 17, negative 2, 1, 0, and negative 15, 2. Okay. And then using this to, what did I highlight in pink? I don't remember. My original function. I'm trying to keep them the same. Okay, and then I'm going to plot those points to show both my original and my inverse. You can go ahead and do that on your notes while I'm doing that on these. So I'm just going to plot these points real quick. Okay, and remember this function is cubic, so we're going to have a couple curves in there, so just keep that in mind when you're drawing your graph. Think back to when we learned about all the parent functions of each of the common functions. And then I'm going to plot my inverse. Let's see, 17, 2. again, rough sketch. Okay. I'm going to go ahead and leave number 6 as self-practice. But before we move on, number 6, what type of function is that? What type of function? Linear. Why is it linear? Because what's another way we could write this function? Instead of writing it all over 3, what could we do with that 3? Yeah, split it up. So we could have f of x is equal to negative x over 3 minus 5 over 3. And that resembles our mx plus b. So this is linear. So just keep that in mind when you're trying this on your own, that your two equations when you graph are going to be linear equations. Okay, moving on to the next concept. We have finding a function's inverse. So remember in the beginning we defined inverse as swapping our x and y values. And in those examples we are just given tables or points. So now we're given two functions and it wants us to see, are the following functions inverses? So we're going to have to take one of these functions and swap out the x and y values to see if we get a matching function. So it would match the other one to see if it is an inverse. Okay, and here's the formal definition up here where it says f of a is equal to b. It's the same as saying the inverse of f of b is equal to a. Notice they just swapped out their variables ab, ba. Okay. So we have two functions for number 7. We have g of x and f of x. So we're going to go ahead and start off with that first function, g of x. I'm going to rewrite it here. And remember, g of x, f of x, h of x, all of those represent what variable? Y. So we're going to just cross this out and say this is a y. Okay, so we have y equals 4 minus 3 halves x. In order to start finding the inverse, we have to swap what? The x and y. So now we have x is equal to 4 minus 3 halves y. And then remember, all of our equations are usually y equals. So here we're going to get y by itself. So what are we going to do first to get y by itself? We're not going to multiply just yet. Subtract the 4, because notice the 4 is in front of that y value. We got to get rid of that 4 first. So we're going to subtract the 4. We have x minus 4 is equal to negative 3 halves y. Okay. Now, how can we get rid of that negative 3 halves?
Divide by negative 3 halves.
So not divide. Good. Multiply. Remember, in order to get rid of a fraction, we're going to multiply by its reciprocal. So I'm going to multiply both parts. Let me change that color here. By negative 2/3. Because if you were to multiply that across, that would become negative 3 times negative 2, which is 6, over 2 times 3, which is 6. 6 divided by 6 is 1. So it cancels out. So we're going to do that on both sides. Okay, so that means on that one side they cancel and we're just left with y. I'm just going to go ahead and move that y to the front of my equation. So y is equal to negative 2/3 times x minus 4. What do you think we should do with that negative 2/3? Distribute. So we have y is equal to negative 2/3 x plus 8/3. Remember, I turned this negative 4 into negative 4 over 1, and I multiply across. Okay. So now we're looking, does this equation we just found match the other equation?
No.
No, so what could we say? Are they inverses or not inverses? They're not inverses. Because once we manipulate that first equation and we swap our x and y values, we should end up with that f of x equation if these were true inverses.
Ma'am, if I may ask,
Yes.
in that middle equation, where did you get that negative 2/3 from? I thought they canceled out.
From right here, where did I get this?
Yes, ma'am.
So whatever I do to one side, I have to do to the other side. So notice how I multiplied this side by negative 2/3. I had to also do it with this side.
Oh.
And all I did was write my y in the front. So that's why it looks like they're on opposite sides, but they're
Yeah, of
not.
course. Okay.
You could have kept it where you left the equals y in the back. But remember, it's just better to have our y in the front.
I forgot that you had flipped it, yeah.
Okay, yeah. Any other questions? Okay. Okay, let's go ahead and do 8 together, and then you guys are going to try 9. Okay, so for number 8, we're going to do the same thing. We're starting off with that g of x function. So g of x is equal to negative 12 minus 2x over 3. Okay, we already know g of x is the same as writing y. And then if we're going to flip our x and y, I'm going to rewrite this as x is equal to negative 12 minus 2y over 3. So remember, from here, we're trying to get y by itself to see if that f of x function is going to be an inverse for g of x. So what would we do first to get y by itself? Multiply both sides by 3, and that's going to cancel that 3 in the denominator. Okay, so I have 3x is equal to negative 12 minus 2y. Okay, what's my next step? Add the 12. Can I combine 3x and 12? Nope, they're not like terms. So 3x plus 12 is equal to negative 2y. And then my last step here. Good, divide by negative 2 because I want y completely by itself. Divide both sides by negative 2. Okay. So again, I'm going to write my y in the front. So I have y is equal to 3x plus 12 over negative 2. Okay. What's another way that I could write this equation just in case my one that I'm comparing it to did not have one fraction as their equation? Good, I could separate them. So this is the same as saying 3x over negative 2 plus 12 over negative 2. Okay, and that reduces to negative 3 halves x minus 6. So these are all the same. Okay, so looking at any of these, does that match our f of x function? It doesn't. And we could even go back up to our f of x function and do the same thing we did for our answer down here and separate it into two fractions. So what would that look like? close. So first I'm just going to separate each of them, right? Just separating them by putting them over 5.
It would be -1 plus 6 over 5x.
Yeah, so -1 plus 6 over 5x. Is that what you said? Yeah, okay, my bad. I couldn't quite hear if you just said 6 or 6 over 5. But yeah, the opposite, we could write it the other way too. 6 over 5x minus 1. That's the same thing. So again, if we're comparing them, do they match? No. So this one doesn't match this one. So that means what? Oh, my bad. Not inverses. So for number 9, you're going to try this on your own and use that concept for g of x by, at the end, to separate that into 2 separate fractions just to see if it's going to give you your f of x. So you guys are working on 9. I'll give you a minute to do that. Start off with g of x, swap your variables, and see if it matches the f of x. Okay, about 30 more seconds. Looks like some of you are done. Okay, so if you're still working, continue working. If you're done, I'm going to start going through this. Remember, no rush to try to write this down. It's all being recorded. Okay, so starting off with our g of x equals -16 plus x over 4. Okay. You should have remembered that g of x is the same as y. And we're going to swap our x and y values. So you should have wrote x is equal to -16 plus y over 4. And then try to get y by itself. So what was the first step that you guys did?
Multiply by 4.
Multiply by 4, and that gets rid of the denominator. So we have 4x is equal to -16 plus y. And then what'd you do next? Add 16. Do we combine 4x and 16? Nope, so this is 4x plus 16 equals y. Or I could rewrite this with y in the front. Y equals 4x plus 16. Does this match our f of x function?
Yes.
Yeah, so that tells us what?
It's an inverse.
It's an inverse. They are inverses of each other.
So it's probably a silly question,
Mm-hmm.
but if we were to graph using random x points, if it's an inverse, would the graph match flipped? Do I make sense?
Like how we were graphing above?
Yeah.
Yeah, it would look like, because if you notice, yeah, it would look like the inverse when you graph, and you notice when we were doing the graphs up here, it did look like that, especially like on the linear one. All it did is the original one just tilted a little bit. And like same with this one, the original one tilted across the coordinate plane. So yes, it would look like that. It wouldn't be two completely different functions. Like you wouldn't plot a linear and then get a quadratic for your inverse. They would both have to be
But I
linear
mean,
here.
can we use a table to solve this if it's an inverse or not?
Oh, I see what you mean. Well, in this specific question, no, because it's just asking you, are these equations inverses of each other? I wouldn't trust just creating a table for each of them, because you just never know, like the numbers that you're picking could give like your inverses. Unless you're gonna go and write hundreds of points on a table and compare it that way. That's just too much work,
No,
yeah.
it's easier.
Okay. Okay, so for these problems, notice how we were always picking g of x and solving it down that way. We could do the same with f of x. I don't have to choose g of x every time. That was just me showing you, okay, if you're someone who needs those steps, just pick g of x. You could do f of x as well. So we're going to start off doing f of x in this problem instead of g of x. So we're still checking if they're inverses of each other. Okay, so in this case, I'm going to start with f of x, and then I'm going to see if my inverse matches up with g of x. So if f of x is 3 over 2x minus 3 over 2, f of x is the same as what variable? Y. Remember, all of those with the of x is y. Flipping them, I have x is equal to 3 halves y minus 3 halves. And I need to get y by itself in order to see if I get the inverse. So what would I do first? First, we got to add the 3 halves. So remember, we got to get the y completely by itself. So add that 3 halves. So usually you're adding or subtracting first to get that first part out of the way, and then you're multiplying or dividing to get the y by itself. So I have x plus 3 halves is equal to 3 halves y. Okay. Now what am I going to do to cancel out that 3 halves? Multiply by 2/3. Remember, multiply by that reciprocal. That always cancels out our fraction. Multiply by the reciprocal.
That's only if we have a fraction, right? If we have a number, we would just, like, that's the whole thing.
So if you're saying if we just had 3y,
No, like if 3y was like the numerator of a fraction, we would multiply by the denominator, right?
correct.
Okay.
Correct. Yeah, if your variable, so you're saying if you had like 3 over 2y,
Yeah, we would multiply by the
yeah, you would multiply by that denominator 2y, and it would cancel it from this side, but that 2y would still be over here once you multiply it on the opposite. Yeah. Okay, so continuing, so we know those canceled out. So we have, and again, I'm just putting my y on the left side. So y is equal to 2/3 times x plus 3 halves. What am I going to do with that 2/3 to simplify? Distribute. So I have y is equal to 2/3 x plus, what's 2/3 times 3 halves? 1, and that's that same concept up there where we canceled it from y, so 1. So now we're checking if this y equals 2/3 x plus 1 matches our g of x function, negative 4/7x minus 16/7. Yes or no? No, not even close. So this does not match this. So that tells us what? Not inverses. And you would have got the same answer going back and choosing g of x as your original equation.
How'd you get 1?
From this one right here, 2/3 times 3 halves.
Oh, it's straight cross multiply, right?
Yeah, so you'd get 6 over 6, which is 1. And that's that same concept up here. That's why multiplying by the reciprocal works, because we end up with 1y, which we can just write as y. Okay. see how we're doing on time. Okay, let's go ahead and let's look at number 11, and then I'm going to leave 12 as a self-practice so we can move on to the next concept. Okay, so number 11, remember we can start with g of x or we can start with f of x. What do you guys want to start with? F of x again? Okay. So we have f of x is equal to 3 plus x cubed. Okay. We know f of x is y. So I would rewrite this as x is equal to 3 plus y cubed. So I need to get y by itself. What's my first step? Good. Subtract the 3. So I have x minus 3 equals y cubed. How do I cancel out that cube? You guys remember? It's close. It's not the square root, but it has a radical in it. The cube root. We would take the cube root of both sides. So remember, if we have that nth root, so in this case 3, match our exponent, which is again 3, they cancel out. So the cube root of both sides. Okay. So these cancel, and I'm going to put my y on the left side. So y is equal to the cube root of x minus 3. Okay, can I simplify that in any way? What do you guys think? Yes or no? Can I simplify that? You should know, we went over it. No, we can't simplify it because that x minus 3 right there. Okay, so we can't simplify this. So now we're checking if this equation we got matches which one? G of x or f of x? G of x. Does it match g of x? No, not at all, because g of x is being cubed, but our new function is doing what?
It's being rooted.
Yeah, cube root. So that 3 makes it cube root, not square root.
In
So-
what instance can we simplify it further?
Well, remember when we were simplifying radicals and we had like the cube root of like 64x to the 4th? We would do the prime factor tree on that 64 and then take out pairs of 3's if we had any. And then we would do that factor tree on x to the 4th and see how many x's we could take out of that. Okay, so it would look something more like this. Unlike this one, this is just x minus 3. There's nothing we can simplify here. Okay, so this tells us that this is yes inverse or no not inverses. Not inverses. Okay. So I'm going to leave 12 as self-practice. And when you do this as practice, you should get that these are not inverses. Okay? So when you're doing this later, you should get that these are not inverses. And notice we have that same concept in here. We have that cubed and that cubed root. Okay, remember we do the opposite to cancel them out. Okay. And then let's see, I'm going to leave 13 as self-practice too. And then again, you should get that these are not inverses. And then just be mindful that your variable is on the denominator, okay? But then we're going to do 14, which is like 13, so. So again, we can start off with g of x or we can start off with f of x. Which one do you want to start off with?
F of x.
Sure, let's start off with f of x. So we have f of x is equal to negative 2 over x plus 1. F of x is the same as y. So if we're swapping variables, we have x is equal to negative 2, y plus 1. Now we got to get y by itself. So this was that idea we were talking about earlier where we had the variable in the denominator. So what would be our first step to get that variable out of the denominator? Good, multiply both sides by what? Y plus 1. Perfect. Y plus 1. And what that's going to do, it's going to cancel out this denominator. And we now have y plus 1 times x is equal to negative 2. Okay. Again, remember, we're trying to get y by itself. So would it be ideal if we distributed that x? No, because then we're going to have an xy, and then we're just going to have to deal with that x later on too. But we could divide the other side by x to move x over. So divide by x. And we get y plus 1 is equal to negative 2 over x. And then what would be our last step? Minus 1. So we have y is equal to negative 2 over x minus 1. Okay. And which equation are we seeing if it matches? G of x. Does it match? So that means what? Yes, inverses. Okay, any questions on this topic? So in this one, we're given two equations and we're checking if they are the inverses of each other. Okay. Last concept here, we are going to now just find the inverses of each equation. Okay, so we're not going to compare it to another one, we're just finding the inverses.
So it's pretty much what we just did without the second half?
Correct. It's exactly what we just did, so more practice on finding the inverse, but we're not going to say at the end, is that other equation the inverse? Does it match or not? Because we don't have that other equation. Okay. So for number 15, we have f of x is equal to cube root of x minus 3. We're going to first do what? Good. Swap the points. So we have x is equal to the cube root of y minus 3. And now we're getting y by itself. So again, same concept we were just doing. Okay. So what would be our first step? Add 3. So x plus 3 is equal to the cube root of y. And how do we get rid of the cube root? What's the opposite?
To the third power?
To the third power, cubing it. Good. So that means we have now just that y by itself, which I'm going to place on the left side. So y is equal to x plus 3 cubed. And you can leave your answer just like this. Or you write x plus 3 times x plus 3 times x plus 3. FOIL, get something. FOIL again, get something. Simplify. I don't need that. Unless you want to. You don't have to. Because this question's only asking to find the inverse. It's not saying find the inverse and simplify your answer as much as possible. Just like on the exam, it'll just say find the inverse. Okay. Okay, for 16, how would I write my equation to start with?
X equals 1 divided by y minus 2.
Correct. X is equal to 1 over y minus 2.
What's my first step to get y by itself?
Add 2.
Add 2. So x plus 2 is equal to 1 over y. Next step, multiply by y, because even though it's going to cancel out on this side, we'll still have the y on the other side. So we have y times x plus 2 is equal to 1. In this case, since we want y by itself, would it be smart to distribute?
No.
No, because what could we just do to the left side to get y by itself? Divide by x plus 2. So both sides, x plus 2. So we have y is equal to 1 over x plus 2, which is the inverse. And then I want to have some time at the end for questions on the test. So let me see. Let's do, I'm going to leave 17 as self-practice because we've already worked a lot with the cubes and the cube roots, so you could use the other questions for help. And then I am going to leave 18 also as self-practice. And then we're going to work on 19. Okay, so 19, swapping my x and y's, I have x is equal to 7y plus 18 over 2. I need to get y by itself, so what's my first step? Multiply by 2. So I have 2x is equal to 7y plus 18. What's my next step? Subtract 18. So I have 2x minus 18 equals 7y. Then what's my last step? Divide by 7. So I have y is equal to 2x minus 18 over 7. Or I could write this as 2 over 7x minus 18 over 7. Both would be correct, whether you give the 7 to just the entire thing as a whole or divide by 7 by each term. These are the same answers. Okay. Let's see. Go ahead and do 20 on your own. This one should be a real quick 30-second problem. Swap your x and y's and solve for y.
That's the lines in the test, right?
No, not that easy on the test. So x is equal to y plus 3, subtract 3. You should have got y is equal to x minus 3. Okay, so I'm going to leave 21 for self-practice, another easy one. And then we'll do that last easy one together. 22. So 22, starting this off, just swapping the variables, we have x is equal to 4y. So what's the only thing we need to do to get y by itself? Divide by 4. So I get y is equal to x over 4, or what's another way I could write this?
1/4.
Good. 1/4 x.
You don't want to do 20 spots?